Hello everyone. Welcome to the video lecture series on Advanced Separation Process. Myself, Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. In this lecture, we are going to discuss about various methods for characterization of membrane. In previous some sessions, discuss about the various microscopic method for the characterization of membrane such as SCM, TEM and AFM. SCM stands for the scanning electron microscopy, TEM stands for the transmission electron microscopy and AFM stands for the atomic force microscopy, which used for the find out surface and cross section feature of the membrane and Fouillon. It's also used for the find out roughness and surface morphology. Then in previous session discussed about the various performance tests to find out the permeability, rejection and pore size distribution using membrane filtration setup. Then discuss about the membrane porometry method to find out the bubble point or bubble pressure and mercury intrusion instrument to find out information on membrane pore structure. Now, in this lecture, we are going to discuss about other methods such as a gas adsorption method and porometry method to find out the information on membrane pore structure. So let's start with gas adsorption and desorption method, which also known as a BET method. So let's start with this BET method. Pressure of condensable gas is increased to provide monolayer then multilayer sorption on internal surface area of pores until full condensation occurs. Then the procedure is reversed. Using graph between filling and empty the pores provide the measurement of the pore volume distribution. The internal surface area at monolayer coverage is then used to calculate pore diameter distribution. In this method require dry membrane and low temperature that may be introduced material artifact. So using this method we can find the pore volume distribution. First we are going to apply the absorption. So this is molecule are absorbed on surface of this membrane, or can say that pore filling beginning. Then monolayer of this molecule are occurs on accumulate on this surface of membrane. Then continuously pore filling occurs due to the absorption process and we will get the multilayer of this molecule. So using absorption process and using this graph we can calculate pore volume. So this is all about the BET method which used for find out the pore volume of membrane, or it's also used for the find out the porosity of any catalyst. Now let's discuss about next method, which is a molecular weight cutoff. Molecular weight cutoff is a method of characterization used in membrane filtration process to describe pore size distribution and retention capability of membrane. It defined as the lowest molecular weight in Dalton at which greater than 90% of solute with known molecular weight is retained by the membrane. This method mostly used for the determination of complete rejection characteristic of membrane, particularly for the ultrafiltration and microfiltration process. This method is based on steric or size-based rejection of solute by the membrane pores. Typically, a membrane of water-soluble molecule and macromolecule is made and present as the feed to the membrane. For dialysis, reverse osmosis, nanofiltration, the mixture will be typically contain mono and divalent salt, urea, sucrose and alcohol. For ultrafiltration and microfiltration membrane, the macromolecule solution can be mixture of protein or polydispersed solution of single hydrophobic polymer such as dextrane, polyethylene glycol is used. To get entire rejection profile, it is required to have expected rejection range from 100% rejection. At lower end, solutes such as sodium chloride and glucose are used since they have expected to a zero rejection by the ultrafiltration membrane. In the high end of the scale, large protein like immunoglobulins or blue extran are used since they have completely rejected by the most ultrafiltration membrane. There should be some other solute or intermediate molecular weight. The molecular mass distribution is measured on a straight feed material, usually by the size exclusion chromatography and SCM. The molecular mass distribution is measured on starting feed material and permeate. The result is curve of the percentage rejection against molecular mass. The membrane is usually rated by the mass at which 90% of solute is rejected. This table gives molecular weight cutoff range for few polymeric membrane. So, cellulose acetate have a 1000 to 50,000 molecular weight cutoff for the tubular and flat sheet module. For the polysulfone, there is a 5000 to 50,000 molecular weight cutoff for flat sheet, tubular and hollow fiber module. For the amides, there is a molecular weight cutoff is a 1000 to 50,000 flat sheet, tubular and hollow fiber module. And for polynitrile membrane, 30,000 to 1 lakh molecular weight cutoff for the flat sheet, tubular and hollow fiber membrane module. Among the main sources of uncertainty are the assumptions of solute rejection based on size alone and the solute shape. Therefore, dimension remain negligible for the process. The participation of macromolecule in a pore is based on size, shape and energetic interaction between the solute and membrane material and concentration at pore mouth. The concentration depends on the condition under which filtration measurement was performed. Also, specific and non-specific adsorption of solute to the membrane surface can occur and overestimation of percentage of rejection. Another source of measurement of uncertainty is the calibration of column. Therefore, rating of molecular weight cutoff should not be taken as a geometric absolute. The result obtained in such measurement are snapshot of membrane transport characteristic under a specific set of measurement conditions. So this is all about the molecular weight cutoff method. Now let us discuss about the particle retention method. Membrane for both liquid and gas separation application are often characterized by the particle retention measurement, and particle rejection is typically expressed in terms of the long residual value, which known as the LRV, long residual value. The challenge level may be a dilute 10 raised to power of 8 to 10 raised to power of 10 particle per liter, or concentrate must be a 10 raised to power of 13 to 10 raised to power of 15 particles per liter. Both monodisperse and polydisperse particle are used. The instrumentation is a typically laser particle sensing and counting with automated data collection and analysis. The particle retention can be occur by both depth throughout the thickness of the membrane and surface capture mechanism. Measurement of particle retention are not without ambiguity. The relationship between the actual geometric dimension of membrane or filter and particle size being retained is most of tenuous if the filtration occurs throughout the filter depth. This is due to the variety of depth filtration capture mechanism that facilitate the retention of particle smaller than the opening in filter structure. These conditions are particularly not worked in gas filtration. Since many contribution to the particle rejection, the filter performance can be changed without time, loading and particle distribution. For instance, under some circumstances, breakthrough occurs such as a loss of rejection after a period of time. This can be due to the blockage of smaller void. It is also true that the majority of convective flow through a filter is carried out by the large pores. Such a situation will also lead to the large pores become partially or fully blocked by the capture particle. Thus, the pore size distribution will be apparently changed with the extension of filtration, which result in overall surface cape buildup, field surface fouling, particle aggression and particle bleed can be changed in filter retention and permeability. So, to find out particle retention, these setup are used. in which this is liquid A, which pass through HPLC pump to the membrane assembly, and this membrane already contain the liquid B. Using particle retention method, you can calculate the rejected particle, and it will be shown on this computer, and it will be record through the graph. So this is all about the particle retention method. So in this session, discuss about the performance stage for find out permeability, retention and rejection, and also discuss about the transmembrane pressure. Transmembrane pressure, which means the average of inlet pressure, outlet pressure and permeate pressure. Then discuss about the bubble pressure or bubble point, which used for the find out the pore geometry. Then talk about the mercury barometry to find out the pore volume, and also talk about the gas absorption desorption, which also known as the BET method, which used for the find out the porosity and pore volume, which also used for the find out porosity of the catalyst. Then discuss about the porometry, where the we can find out the pore volume using O2 analyzer or any gas analyzer that pass from the membrane. Then discuss about the molecular weight cutoff, and then finally discuss about the particle retention. So this is all about this lecture. I am completing my lecture here. Thank you.